All right, from here we're going to move further to talk about the laws of electrolysis. Faraday's first law of electrolysis. So now I can take this out, and the rest we can always remember. Hydrogen is down here, copper, this and this, these are down. After hydrogen we have copper, hydrogen, argentum. Every other guy is above it. Why are we interested in dealing with hydrogen? Is because in all aqueous solutions there is always hydrogen. So we must know the position of hydrogen comparatively to the metal that will be confronting it. Only copper is below hydrogen, hydrogen, and argentum. So in the electrolysis of silver chloride will be discharged and not hydrogen, because hydrogen is higher than silver, and so on and so forth. But lead, nitrate, blah blah blah, hydrogen will go, tin, iron, and so on. So let us go back. Let me take this out. Okay, Faraday's first law of electrolysis. Faraday's first law says that the mass of a substance deposited during or liberated during electrolysis is directly proportional to the quantity of electricity that passes through the electrolyte. So the quantity of electricity that passes through the electrolyte must be directly proportional to the mass of that substance. Now, the quantity in its own sense is Q is equal to IT, current times time. But from here, if I can move further, I'll say mass is equivalent to KIT, where K is the mathematical word constant. So M equals to KIT, where K is the mathematical constant. Now, if I want to make K the subject, K will be equals to, because I have to divide both sides by IT. For me to do that, I have IT. So from here, M equals to KIT, this IT will cancel IT. So K is equals to N over IT. Now, if this were to be reversed in a reciprocal form over 1, this becomes 1 over K is equals to IT over N. This will be required when we get into mole and mass relationship in electrolysis. But we said again, first law of electrolysis, Faraday's first law, that the mass of the substance liberated or deposited during electrolysis is directly proportional to the quantity of electricity that passes through the electrolyte. That quantity would define the ability of the electrolyte to dissociate. The quantity of electricity that will pass through will define how the electrolyte will dissociate. That is, ionize or decompose, as the case may be. So this is it. And here we can move further to take some questions in order to address what the Faraday's first law of electrolysis says. So I will begin by taking some questions in relation to this. So let me take this out. Remember, Q is equal to IT. So whenever a question is given, it is also imperative that you state out the given variables. So while I read the question, I will list out the given variables so that I will know exactly what I am dealing with. Now, I have a current of, current is I, a current of 0.72 amperes was passed through a solution of an electrolyte for 3 hours. So time is 3 hours 20 minutes. Calculate the quantity Q is equal to, we don't know, of electricity that was passed. So this is a direct question, doesn't need us to think too much. We'll move further to proceed. Remember we say that Q is equal to IT. And that's what we're asked to look for. So all we need to do is to multiply our current and our time. That is all. But the time here is in hours. We have to convert the time into seconds. And do not forget, for us to do that, the time, we say 60 seconds make 1 minute. 60 minutes make 1 hour, which means 3 hours will be 3 times 60 times 60. So by that I have 3 times 60 times 60 per day. Plus 20 minutes. So I have 20 times 60 because 60 seconds make 1 minute. So if I should add all of these, I will have 3 times 60 times 60 will give me 10800. 10800 plus 20 times 60. 20 times 60 will give us 1200. Now 1200 plus 10800 will give us, okay, that's 12,000. 12,000 seconds. I need to be certain again. I have 10,800 plus 12,000 is 12,000 seconds. So this is my time. So I've converted this into that. So I'll now have 12,000 seconds. So the formula says Q equals to IT. My Q would therefore become, I first of all is 0.72 amperes times the time is 1200 seconds. And this is equals to 12,000 times 0.72 is equal to 8640 coulomb. The unit for quantity is in coulomb. Take note. The unit for quantity is coulomb, which is the same unit as Faraday. So when we get into, when we'll be dealing with Faraday, we should know that wherever we see coulomb, we can use them to be the same thing. So we shouldn't confuse ourselves with that. Let's take our second question from the first law.